Okay, so I hope that you all had a great lunch and that you're all fresh and ready for more. Our next session is going to be about the digital perspective, and it will be moderated by Marco Steinberg. And I will give it over to Marco.
Thank you, Julia. We'll just put this down here. So it's a great pleasure to moderate this session. Thank you for the invitation. I thought I would just say a few words about format and then do a very brief introduction to the theme, because as I was making the argument to our panelists over lunchtime, I think this term is a relatively new term to our profession and may warrant a bit of context. So first of all, we have Greg Lynn giving a keynote speech. Greg's going to stop a few minutes early. You're going to stay on stage. I'm going to jump on stage. We'll chat for a minute, and then we'll get off stage. And then we'll do the 3 presentations following as a sequence, and then I'll ask the 3 sets of presenters to come on stage, and we'll have a bit of a conversation. All right? So that's just in terms of format. I think when we look at the terms we have, which are material, social, local, and digital, the first 3 terms are terms I think that our profession has engaged in with a long history. Materials clearly have always been part of what we're doing. The social aspect and the local aspect is also. But the digital is fairly new, so I thought just a few personal notes on that, also as a way to prime you for what my biases are, so when we get into conversation, you'll know why I have certain blinders on. I think and we look at it in the context of JYVÄSKYLÄ in Finland, if we look at this, I think the Aalto generation was a generation of architects that helped in a tremendous transformation. Finland is an interesting example. If you look sort of pre-1950s, more or less, we all lived in the woods. Post-1950s, we had health care, schools, systems, the welfare state. It happened basically overnight. And the big transition was from an agrarian state to an industrialized state. We needed architects there to build cities, to build factories, to build housing, to build places of congregation, et cetera, et cetera. I think we're undergoing another big transformation, which is this transformation into this digital era. And we've seen it shape and transform in very radical ways many of the things that we've done in the past, the way we do transactions, the way we share ideas, the way we connect, and it's also clearly shaping the way architecture and the profession itself. And that's basically sort of maybe the context of this, is really to think of it in this big second transformation that our society is going in the last probably 100 years or so. I was thinking about this idea that digitalization and the promise that it brings. Some of those promises have been there for a long time. Now we finally have the technology to do some of these things. But one of the examples we could go back in history is Brunelleschi's dome in Florence. One of the big mysteries is how could somebody build such a dome? It's still the biggest masonry dome in the world. And actually, the solution is very simple. There's this beautiful flower that Brunelleschi came up with, a series of ropes, and as long as the ropes intersected and followed the path of the flower, the spinning ropes would show where each brick is laid out. So you had a set of instructions, you had a machine, basically, and a way of actually dealing with very complex geometric shapes. And it was a big transformation. I think this is kind of the promise of how we make things. We're beginning to actually see that being actualized. I personally got interested in sort of CAD/CAM in the early 90s, in the vein of Eames and doing complexly molded plywood. How would that be transformed? Could we bend wood in very complex ways and shapes? I think it came out of a vein of working as an architect with materials. But I think this tree is also branching out. We're getting into very social issues, how we make decisions together. We're getting into ways in which how do we transact on ideas. We see Kickstarter, for example. How do grassroots ideas merge? Lots of fabrication, lots of things where we're actually working directly with materials or directly with people. And I think today we'll see what that tree looks like, and we'll talk a little bit about that. That's enough in terms of my brief introduction. Let me introduce, and I promise our panelists I do very informal introductions. So our next speaker is Greg, who needs no introduction, but has probably been one of the grandfathers of sort of, is that a bad term?
I think we're good on the
enlighten the visionaries. Enlighten visionaries on the digital, and one of the early movers, and I would characterize probably more than running a business, running a research agenda, a professional research agenda. So Greg, let me help me in welcoming Greg. And then
Thanks,
there's a little clock here for you guys.
Can hit start. Okay, so I brought a little bit of a mix of things, some old, some new, really to make a point that for me, I think the digital in terms of fabrication is now ubiquitous. I think most schools of architecture, most offices, you see laser cutters and CNC mills, and architects now know how to talk to the machines that have been building buildings for now a long time. I think I'll show some examples of it, but for me, I think where the digital is going now is it's moving past using the digital to be a carpenter, and now is looking at how to make things move, how to locate people in space, and how to make smart environments that are, in some cases, even transformable. So to go back a little bit, and I tried to make as many connections with Aalto as possible. I really think I was saying earlier that when I go to an Osplin building, I want to find out where to stand. And I would sit there and I contemplate it. When I go to an Aalto building, I know immediately that I'm being asked to move around. And I think that there are really two very different approaches to architecture. One, like Aalto's, is very much about capturing motion in form and space and getting people to move and leading them along paths rather than asking them to sit and contemplate. And for me, I know I've always been interested in curves and the geometry of curves, and Aalto is really one of the precedents for me of looking at a certain way of drawing curves and realizing curves in space. So the composite curves of Aalto with these multiple radii, even as like a 19-year-old, I knew this was a good way to deal with the thickness of materials and construction, and went to a school specifically to study with architects who knew Aalto's work and these kinds of techniques, and also how these could have local changes, and you could develop these things in a way you couldn't do with, say, ship curves and things. So what drew me to the digital, frankly, was how much I hated ship curves. And I was really destroyed the first time I came to Finland and went to Aalto's office and studio and saw all these French curves and ship curves laying around, because I thought that was really debunking something that I'd believed in. But the reason that I didn't like them is because it was so hard to deal with material thickness, and also in order to scale them, you just had to buy bigger tools. And that seemed very impractical in terms of construction. So I never liked these kind of ship shapes of Aalto and these kinds of tools. Although, when I looked at Aalto's work, I did always see, what I would think of as kind of frustrated boats. Like that to me is a thing that wants to be a boat more than a building. And my schedule changed. I really wanted to go see the experimental house, not to see the house, but to see the boat. But anyways, there's Aalto really happy on a boat. And I started to notice, like all the architects I like, I mean, even the ones I hang out with, we all love boats. And so I was thinking about why is the curve and the digital and the boat all connected together. I think one of the things is just that, unlike a building, which sits there and tries to convince people to move through it dynamically, very much like the lobby of this building, it's a very dynamic space, boats actually move. And I think that's probably what's the best about them. What's the worst is that boats have things like cabins and salons and all these kind of antiquated 19th century qualities, and they're not boxes. But I think it's because they move. So anyway, one thing I want to connect with is Aalto's boat and this idea of an architecture in motion and objects in motion. There are some drawings of the boat. I'm sure everybody knows the boat better than I do. But you'd also know it was an Aalto boat in a minute. I mean, not only from the window, but it's not a very ship shape. Um, but so anyway, this love of curves and of ship curves is what brought me to the digital, and it's because I started drafting. When I went to Princeton, there was one German student there, and this German student had these rubber things called splines. And I went out and bought sets of these things, and they were used by freeway engineers, but sometimes naval architects to draw repeatable curves. And this term spline I saw on, I think the first package of software I had in 1984 was Bentley, what became MicroStation, and it had a tool on it called a spline. And so I started investigating that, and from that moment on, I did all my drafting digitally rather than mechanically. But it was really about trying to find a curve. So this model, the first thing I did when I left Peter Eisenman's office was literally like a drafting tool turned into a model that was then used to draft all the geometry of the project. And that was the last thing I ever drew by hand. To follow with this kind of boat theme, in the 80s, everybody talked about lofted forms digitally, which meant that you would take one set of curves in one direction, like ribs on a boat, and then loft them, which is a term that comes from boat building, with another set of curves through them. And the Cardiff Bay Opera House competition, which was the first competition I ever did, we started with this diagram of what used to be on the site. So the site for the Opera House was a dry dock. And what's great about this is if you look at the dry dock, if you look at the dry dock, you'll see this machine which has all these pins, which are the pins right there. The pins all rise to a different height. The pins are all then connected with a flexible set of ribs, and that way this machine can accommodate itself as a cradle to all different kinds of boat shapes. So this machine, you're going to see in a minute, reproduced in digital format for making these kinds of molds. But anyway, for this project, it was all about using these, I would say, kind of algorithmic processes of branching, which were drafted mechanically. And then we fed that mechanically drafted information here into a computer simply for rendering. But it was the first thing we ever lofted. And this, I forget when that competition was. It was something like 91 or something like that. But anyway, this theme of building surfaces like you would build a boat was very much the standard, the industry standard at that time. So the digital spline works in a very similar way. You set fixed points, and instead of those discs, you actually draw an infinite set of points between them, and you loft those things together. At the time I was showing some of this, I was showing process in public, and people were saying, well, these motion-derived forms mean that what you're saying is that the end point of architecture is that the building should move, like Archigram in the 60s, and haven't we all seen this already? And I in a reactive way, wrote this book called Animate Form, where I used an example of a boat to not make moving buildings. And I think the point, I'll just read it. The particular form of a hull stores multiple vectors of motion and flow from the space in which it was designed. A sailboat hull, for example, is designed to perform under multiple points of sail. For sailing downwind, the hull is designed to plane. For sailing into the wind, it's designed to heel, which means lean over, and present a greater surface area. So my argument was, in one shape, you could have all these dynamics built in, but the boat shape never has to physically change. And it was for me to avoid ever dealing with a moving building. And I was friends with people like Chuck Hoberman and David Rockwell, who were all doing moving buildings, but I thought, this is really someplace I don't want to go. So instead, I used the digital for fabrication, and I realized, ironically, very much like you'd expect an architect to use a tool. And frankly, in my opinion, it got out of control really fast, because what I did is I made things more complicated than they needed to be, which is what architects tend to do. And I also focused it towards tectonics and a celebration of details, which architects also do. So here's one of the first things we did is we used digital tools to program the path of tools for cutting components. So I thought, well, let's use these things as bricks, and I'll digitally array the bricks along paths. I'll find out how they all fit together, and cut them with a robot and fit them together into pretty much the most complicated thing you could ever try to do with a brick. We then commercialized that with Panelite into this blob wall system where we did a bunch of these things for interiors and things, these fountains. But again, it was to celebrate how much complexity you could achieve using a digital tool, and it was to make the details as intricate and complicated as possible. So for me, I would call this the period of tectonic maximalism. This is like where Patrick Schumacher and parametricism lives. It's escalating the uniqueness, the fineness, and the number of components, and making sure every component is unique in the way that it attaches to the next. And I mean, with the Korean church, that was really the whole agenda we had in terms of tectonics, was making every single element of steel unique, making every single interior surface unique, all in a rhythm, I mean, which I would say is in this tradition of Aalto, of visual movement of your eye through space, but trying to make everything different. So something really kind of important happened to me, and that was a contact with Rolf Fellbaum from Vitra, where he asked me to do a chair. And if you ever do a chair for Vitra, first thing he does is terrify you and tell you that, you know, lots of architects can do good buildings, but very few people can do a good chair. And he said, you better bring 3 proposals. And I guarantee I'm not going to like any of them. So I came with 3 proposals. One was a 3D printed chair, which was like the most ridiculously complex thing you could do. Another was like the blob wall, built out of components. And thank God I had the third one. But so when I presented them, I said, look, using digital technology, I can make a chair with more than 10,000 parts, and everyone will be unique. And he just looked at me like I was crazy. And he said, that's not innovation. Innovation is making a thing with fewer parts. And I said, oh, he said, you're such an architect. Like, only an architect would say, I'm being innovative, I'm going to make the thing more complicated with more pieces, and everyone's unique. So anyway, what that led to was this Ravioli Chair, which is a chair made out of 2 pieces. So if usually a chair like that is made out of 3, 4, 5, 6, 7, 8 pieces, hard pieces, plus all of the soft components, this is just made out of 2 parts. There's one part which has 3 kinds of foam injected into it, and it's digitally knitted so that this distance is 2.5 times the length of that distance, so it has a bunch of knots in it. It's like these shoes. But it's really just, it's 2 parts. So what used to be legs, all is done with the job of a surface. What used to be arms and a back and a seat is done with a second surface. So this move towards using curves, not to animate components along, you know, not to come up with 10,000 pieces of wood, but instead to use curves to capture as much information as possible and to have as many orientations as possible, really became kind of my mantra. So, you know, in products, we've done that, and then taking that up to the scale of a building, it really becomes a few techniques for me. One is, how do you take the surface of an interior and build in as much ergonomics, equipment, and let's say modulation as possible in as few surfaces as possible. In the exterior, it's how do you use a laminated skin structurally, so instead of escalating the number of skins, start to reduce them. And then finally, try to think about space where instead of having a bunch of rooms, you can modulate space with surfaces. So best example I have of that is this Bloom house. You can see it's on the beach in Southern California. And it's an infill, so we're just maxed out height and width-wise, so it's a zoning block. But within that zoning block, we tried to make an intimate space that's an open plan. So the ground level, you can see, it's all one room, but that one room is modulated by changes in the floor height, but also folds and curves in the surface of this wall and that wall. And then in the section, same thing, we kind of bring the height down by folding the ceiling down with this element. So, and then there's really kind of one window at each level that stretches like a ribbon and kind of pinches closed. So the other thing is the contractor that built this, Bill Chrysler built this luminous fiberglass lantern, which runs down the length of the house. And then the contractor is also a sailboat racer who got me to buy. We bought the same sailboats and raced each other for about 5 years. And Bill, you'll see, comes back again with boats with this thing that he did. But so in the house, everything from the off-the-shelf firebox to all of the kitchen equipment, all the bathroom fixtures, it's all absorbed into these two surfaces. So one wall ends up doing as much work as possible and gets articulated in its ability to swallow up all this equipment. The other thing, it just came up. I mean, we did drawings, but almost all the framing for the house was done with a set of digital files that went straight to a laser cutter to laser cut the framing for the house. All of the furniture that was built in, that went straight from a digital file to DuPont. We actually invented the way of molding it for DuPont and patented that. I'm really against hardware. Like, I hate metal. I hate when an architect says, I'm going to use carbon fiber, and they use carbon fiber, but then they connect it with a bunch of stainless steel joints and brass brackets and things. So I'm on a one-person mission to eliminate metals as much as possible and use glue. Like, I love glue. So, so you can see all the handles are all custom made, and these were €6 a handle, by the way, to make. So like kind of IKEA prices for this house. But anyway, we tried to get all of that extra busy, fussy architecture detailing out and get it all into the surfaces as much as possible. In the bathrooms, all the mirrors and cabinets and even the sinks, they're all incorporated into this monolithic surface. So working on this pushes you immediately into the world of plastics and composites. And so here at Site Santa Fe Museum in Santa Fe, New Mexico, we did this recladding of it where we worked with kind of large-scale carbon and fiber-reinforced plastics. So, and this is outdoor. Same stuff as we built inside the Bloom House. And I've been working to scale up this kind of composite language larger and larger for a stadium in Turkey. This actually is a good example. Harry Cobb is a person that has the most interesting things to say about material, and he's always made the case that at a change in geometry, you never change material. So here we were playing with using the same form, but kind of arbitrarily changing the material on that form to make things that are whole and differentiated. And because of that, Nadia Swarovski came and asked us to do this jewelry. Same thing at a completely different scale. But again, all with plastics and composites that lend themselves to a different way of constructing things, not always articulating corners and joints, but instead trying to blend across surfaces. Okay, so where I know Renzo Piano, Frank Gehry, Norman Foster, number of architects I've spoken to, the minute you mention certain kinds of construction, they all refer to this Prada ad campaign that we all saw as we were going through magazines, and they were using this to sell clothes. But Prada had an America's Cup team, and they were the one team that was using this technology of sail making by North Sails, which when I saw it, I immediately thought, that looks like an architectural drawing. You know, it looks like the cross-hatching in a Palladio drawing or something. You know, what is that material and how can we use it in a building? And all those architects I've named have all used this material in a building in some way. But I searched out the company that makes that and got to be very good friends with the person that's the inventor of it. And what's, I think, intuitively you understand about it is that the structure is placed in the path of the loads. So instead of having structure be orthogonal and generic, the structure is bespoke and it's only placed where you need it. So that idea of a load path structure, I think, is a very powerful idea. Also, the fact that the fineness of the structure is now getting to be like a drawing also makes it incredibly interesting. Going up to see how they make it, that's the thing I was saying, it's like the Cardiff dry dock, but they have a big deformable mold, and they actually make these sails on the deformable mold so that the shape of the sail is made when they cook it. And this kind of composite is something where the glue is on it and gets activated with heat. So they lay it all down, then they go over it and they cook it and they vacuum bag it and thermomold it into a kind of a semi-rigid shape. So over the years, I've worked with this material, again with Swarovski, to hang crystals for exterior shades and interiors. And then also we did what I'm proud to say is the lightest chair ever made. This one's about 8 ounces. But it's a tensile chair that doesn't hang in a tensile shape. It's so strong that when you hang it up, it just takes the shape of the mold that it was made on. But then the minute you sit in it, it turns to fabric. And so this was sent to the Art Institute of Chicago in a FedEx pack. So you can just fold it up and put it in an envelope and ship it. And then you take it out and just snap it, and it snaps right into shape. But these kind of high-strength, lightweight, moldable fibers, you know, for me, are a material that's native to digital construction. Okay, so it was inevitable that I would have to design a boat for myself. So I thought I'd bring it because it has a lot to do with digital fabrication, but also kind of coming full circle to digital tools. But first, to give you just a kind of overview of where things are at. Designing a boat is very low-hanging fruit because they're very badly designed. They're designed by engineers. The ones that tend to have design are designed by architects, but only architects who are kind of in that refinement mode. And so I think this is a little bit of a fairy tale about where architecture could and should be. So this is Jack Seaton's boat, Ciao Gianni. For me, it's the best boat of this type ever made. I don't think anybody will do a better one. It's a refined boat in the sense that there's almost no hardware, there's almost no interruption of the surfaces. It's very elegant. It's very tasteful. It looks a little bit like a boat should look. I mean, it looks like an old boat, just very cleaned up and new. You know, it's equivalent of a Swiss box for me. And the paradigm that it works under is be as long as possible and try to displace as little water as possible. But so this boat works by just digging a hole in the ocean. It just tries to dig as small a hole as possible. And it does that by being lightweight, and it does that with shape. And that's been kind of the paradigm that boats have been designed with for 80, 90 years anyway. Make them light, make them try to displace as little as possible, and then just refine the shit out of them. Okay, this is where boats are now, which is instead of worrying about refinement and displacement, apply aerodynamic tools to water and just fly through water. So this is a boat called a Foiling Moth. About 10 years ago, people started putting wands like this and wings on them. They fly out of the water. They go 30, 40 miles an hour. There's nothing like them. But what's great about them is they're completely hacked together of all of these different components. It's not a project about refinement. And the only reason they work is because you can apply digital tools to the design of all those appendages in the water. It's not a common sense and experience approach anymore. It's a digital approach. So for the design of this boat, I worked with an architect, a naval architect, Fred Karubla, who'd worked with us on a lot of engineering of composites already. And he just came in the office full time. And we pulled together a team of people, and we did coupled aerodynamic, which is the sails, which makes it move, and hydrodynamic, which is how it moves through the water, analysis. And it was like the 80s again in the sense that it was all particle modeling and computational fluid dynamics. And we would have to send something to an array of 60 computers overnight and get something back the next morning. So it wasn't intuitive. I started with the interior. I actually thought, what's the minimum amount of space I need to get to Hawaii with one person? So that's kind of as much as I need, and it had to be 7 feet tall. And that envelope was then modeled, and that's what set part of the shape of the hull. So that's like this edge is there just for the interior volume. And then the rest of this is just for sailing. We, then put a series of options on it, and we would send out, maybe half a dozen of these every night, and then get back the results on those half a dozen. And we went through that cycle digitally, where we would take these forms, and so here you can see this line now is there for buoyancy. And we would put these things then through, like that would be the platform we might send. That's one of the examples of what we'd send. Then we would send it through for a computational fluid dynamic analysis and then get it back. And we would do that for the rig and for everything. So you can see, red is bad, obviously. And we would refine it based on this kind of data. But so it was there was intuition involved, there was digital verification involved, there were experts involved, and we would go through this process over and over again. Same thing with the aerodynamics. The boat is fast enough that actually air drag is a big deal. So we would also find out where flow was separating off the surfaces, and we would then remodel those surfaces to get rid of that flow separation. A lot of it we built ourselves, meaning in the office, kind of evenings and weekends. So I've had a big CNC machine in the office for about 15 years. And so we cut these molds in foam and then coated them with a mold release agent and then laminated them, vacuum bagged them, and then we would put a core in between the two skins, laminate them again, vacuum bag them again, and then weigh everything. So we have a one-bedroom house of furniture that weighed, before we painted it, 55 pounds, so like 26 kilos. And then after paint, it almost doubled. So the paint weighed almost as much as the parts. And we delivered that to the builder before they ever started building the boat. But what's interesting is we decided to use the same technique. Well, and here you can just see we integrated everything into these surfaces. Surfaces have to do everything. So for the builder, we supplied some of the tooling, which is the most expensive part of the boat, using CNC cut panels that they put together. Also, what's great is what you're going to see was built only out of this material. So when we did the index pavilions, we found out carbon is the new green material. Like we looked at wood, because the index awards are from Denmark, and we looked at carbon fiber. Okay, carbon fiber has Japanese nuclear plants burning glass to make the material. But carbon fiber is better for the environment than wood, because it's stronger, lighter, lasts longer, and you don't use much at all. So what you're going to see was built entirely out of these 2 pallets of carbon fiber and that pallet of foam, and one big bucket, big barrel of glue. But so we could make something bigger than a building out of just that much material. So, and it's indestructible. So part of the molds we made the old way, like this. But the other molds we made exactly like the furniture. So this is a block of EPS foam, which, by the way, gets chopped up and recycled again. So this big EPS foam, this is about 20, 22 meters long. And there's a giant mill. I don't see a person around for scale. But that's the mold that it made. So there's people. So those molds were then shipped down to the boat builder, filled a little bit, sealed with the same stuff. That's the rolls of carbon. And then that gets laid up, just two skins of carbon, except where there's reinforcement, then 3 centimeters of foam that gets vacuumed down to just consolidate it, and then you get the finished parts. Now this is one of the arms. If you support it at one end in the middle and have 100% cantilever, it deflects a centimeter with 13 tons on it. And that weighs less than I do. So like, I could actually carry that myself, but 2 people could carry it around, and it's 7 times stronger than its steel equivalent. So you use very little material. It also has 120 layers of material in the center, and it tapers down to just 6 at the end. So unlike a beam where you have the same amount of material for the worst case, this is all bespoke. It's all glued together. There's not a single piece of metal anywhere on the boat until you have to have like hardware. And the interior helps reinforce it. I'll just go to, you can see it work. All the platforms for all the hardware was all designed as it was being built, and we built all those parts, and they just glued them all down. So everything's very integrated. It's like, in terms of being minimal, it's much more refined than a lot of the other stuff, because all of this is integrated in rather than, because it was designed ahead of time. You know, like I said, it's really easy to do a different kind of boat because there's not a lot of experimentation, but we played a lot with material and color. Even like this is done, because I'm from Southern California now. Oh, this is all 3D printed too. A lot of the details are 3D printed. Instead of, like I said, instead of metal, everything's done with high strength fibers. So this is 3 times stronger than its stainless steel equivalent, and it's very light in comparison. So we had a hot rod pinstriper come do all the painting and pinstriping. And then this is it, driving. You can see getting launched, you know, the whole thing weighs less than 2 tons. My old boat was around this size, and it had an 8-ton piece of lead we had to carry around to keep it standing up. So I could have 4 of my boats and still not weigh as much as the lead I had to carry around in the old boat. That's it in the water. I've got a couple videos of it sailing. Oh, the one other thing is that what's unlike other boats, if you see that shape, that's an airplane wing. It's actually taken from the human-powered airplane prop profile. And what that does is it lifts the boat out of the water as you sail. So you can see here it's halfway down. So you can see there's very little of the boat actually in the water. These things carry 3 tons of load as you're sailing. What's really great about design is this is me and 4 friends, and pretty much in the sailing world, we're very hated right now because we're just 4 idiots. Like, we're not very good sailors. But this is the first race we did, and out of 120 boats, we were the first by like 10 miles on a 30-mile race. And we sailed past 80-foot boats with professional sailors on it. In a minute, you'll see a 2-time Olympian who wrote the rules for the America's Cup. We sailed right by him. It really shows that design can be everything. Like, very little skill, whole lot of design and engineering. Yeah, that's the 2-time Olympian. But anyway, and you see that the key to everything is that piece of orange carbon right there, which the next day we actually sheared off. And what's really cool is these are my kids. So, one adult can go out and, take kids around at 20, 25 miles an hour. That's a 6-year-old. But you'll see for comparatively, yeah, they're cold and wet though. In a minute, you'll see comparatively, there's this powerboat that sent me an email the next day saying, like, what is that thing? I couldn't keep up with you. But it's because where I live, I'm 26 miles from the greatest islands in the world. And it's usually a weekend trip to go out to them, but now we can get out to them in about an hour and a half. Anyway, so what that did, I would say, is it re-excited my interest in things that move. And it's very funny how when you do something completely off of your business plan like that, it brings in all kinds of new opportunities. I've always, invested in my intuition about things because so far, every time, from buying a $70,000 Silicon Graphics computer, which seemed crazy at the time, I made a career out of that. And same thing, really quickly, this thing has turned into all kinds of new ways of thinking about buildings. This is a lab that we have set up where, using Maya, we can control 2 industrial robots very interactively, and it's let us simulate a whole bunch of stuff with the students. But it was really what got me starting to think about moving stuff again. This was for a grant we did with Salk Institute on perceiving moving patterns on a moving surface. But it got me thinking about motor functions and robotics again to move stuff. So for the London Olympic competition with Christian Moeller, we made a proposal. It was us, Zaha, and Anish Kapoor. Anish Kapoor won and built that red tower, but it's for that site. And what we did is we built a dome like a boat, like a carbon fiber dome was the proposal. And it would sit on 3 columns with a robotic arm at each column so it could move the dome and the dome could follow things happening on the site. And that was Christian's part of this, was to think about how it would interact with the crowds and the Olympic venue. But it's the first thing I ever did thinking about a moving building, and that was whatever that was, 5 years ago. I was asked to do, and this was right after we built the furniture for the boat, and I had a surfboard maker employed in the office and a naval architect, and they said, well, we have this budget to build a domestic room. Can you do a room? And I think they thought I would just design some furniture or something. So instead, I used the carbon fiber laminator of the naval architect, and we came up with this rolling interior. So here, if you look, there's a bed with a nightstand, and up there is a dining room table that has a light on the bottom. And so when you turn it, the dining room table stays there, just like the gimbal on an old schooner or something like that. And we built a 1/5 scale model of this in carbon fiber, and also built the robotics and the controls for the base for this Belgian festival. You can see here, that's the digital test. Then this is a small 1/20th scale model with all the furniture in it, also being digitally tested here on a kind of universal KUKA robot arm. You can see in the background is the larger one. So, and then these are the molds. That's the carbon part. That's it in Quadric. But so what we learned how to do was to build with these stepper motors and gearing and the interface preset robotic control system. Mark Zuckerberg saw it, and well, actually Frank Gehry showed it to Mark Zuckerberg. Zuckerberg asked to have it up at Facebook, spent 3 months at Facebook, spent 2 months at Red Bull. It's unbelievable how that world got interested in a room that could move. And from that, and we also, before we sent it to Facebook, we built a little interface using TouchOSC that people could download on their smartphones and position it. Because the first thing, 2 people from my office went and set it up, and they said, this is going to be a nightmare. I said, what? They said, well, Mark Zuckerberg got in it. They said, everybody wants to get in it. I said, well, they're going to break it. They said, yeah, but they want to interact with it. So we made this little application they could download, and then they could drive it around while they were having coffee or whatever. So the combination of building that little interface that, that would let you move it where you wanted it to go, and having it up there, like instantly somebody came down and said, hey, I've got this company, and we're at the intersection of the digital and material world with retailing, and I was told you're the person that I should work with. And he said the task they had is that they had no physical identity, and that accidentally they were sending out messages about the company that was off-brand. He also explained that these objects, these pods, had a very sophisticated antenna sensor in them that needed to be up in the air to work. So 2 things happened. One is, before I ever started working for him, I invested in the company. The second thing is, I looked at it and I said, well, this isn't a commission. You're actually asking me to do the branding for your company. Like, this is not an architectural service, even though you just want a little building. What I'm actually doing is taking your digital identity and giving it a physical identity, and that's actually a whole different scope of service than just designing the building. So I'm now deeply connected with this company, Curbside, really as one of the, as an investor in the company. So what the company does is it's somewhere between online shopping and in-store shopping. So you access the retail inventory of stores. They have about 50 targets right now in Northern California, but they're working with Westfield, which has 1,400 shopping malls in North America, and Target, who has 4,500 stores in North America. So we need to build, tens of thousands of these things. And you buy stuff from the store, it gets aggregated into a bag, and once you're 3 miles away, they know you're close, and they move the bag out to the curb, and you pull up, and they just throw it right in your car. So they started with an Airstream trailer that they polished and put their branding on, and they could afford to do a few of those, but then it got very expensive. Then they started just storing the bags inside the shops and having a sign for the pickup, and that was very inefficient as people started to come pick the stuff up. Then they went to these tents, which looks like they're trying to get you to buy a credit card or something like that. So we needed to replace this with something that can be a digital pin, like a navigating device, which is from their interface, and this covered kiosk. So, and it has to be visible in a sea of parking. I mean, you have to navigate to these things from roadways and freeways. So also what it does is it follows you as you move. So this is still on the 17th of August. We launch at the Glendale Galleria with the first one. That's just a rendering of it, but where it goes. And that's the finished prototype. And you can see the pin on the top. Oh, there, it's always in the same position. That's their logo. The pin it swivels like a periscope on a submarine or something like that. It also, the interface on your phone changes color to match the color of the interface. So at a very dumb level, if there's 3 of them, you know which one to go to because it'll match the color on your phone to the color of the display. And that's from a while ago, one of the first tests we did to see if it would follow and change color. But so anyway, that for me is where the digital is right now. It's about integrating motion and intelligence and interactivity into buildings, and it's about joining with technologies, like curbside, to rethink the urban environment. I mean, what was very funny about this is to go to Glendale, the planning department wanted to know, they wanted to know how many cars would be stacked up here if they were going to have a traffic problem. It triggered like a whole investigation. I went into our, not our Rolodex, but our contacts, and got our traffic lawyer, we got our zoning consultant. I started to line up, I would say, about $75,000 of retainers of people that was going to take months to work with. And because they're a Silicon Valley startup, they said, okay, fine. But while we're at it, since all of our employees have cell phones with cameras, we're going to ask them to record every transaction. So in 2 weeks, they had 50 different test cases of every transaction recorded. They gave it to their website person. The website person filtered it all down, and we found out the average transaction time was 10.7 seconds. And we took that to the planning official. All they needed was the data, and we were done. So the normal architectural way about going through it would have taken us 6 months. Their way ended up taking a couple of weeks, and actually gave us better data because they were the only ones that could answer that question. So that approach of technology and the digital, to me, means a whole different kind of typology of buildings and urban experiences. So, and then one thing I would say, we don't really have that much to show right now, but over the last 6 months, I've started a company with Piaggio that's a US company, which is dedicated just to this topic, how to take what Piaggio knows about urban mobility with the lightweight scale of scooters and integrate it inside buildings, into cities, onto sidewalks. But really they're saying, like, we need architects to tell us how to do that. So, thanks.
So, Greg, I thought maybe just a couple quick questions, and then I believe you'll be around, but I believe you're not going to be around tomorrow for.
Nope.
So, just so you know, he's given us proxy to speak on his behalf.
You're
so
deputized to say
I'm
anything.
deputized and all of that. But if you want to talk to Greg, grab him at the break. But I thought this was a very interesting journey that you sort of charted, and it was clearly also a very personal journey, but I think characterizes quite well sort of the preoccupation the profession has had, which probably started in a much more formal, let's see what we can do, to maybe a more cogent, more strategic way of thinking about these tools. I liked where you ended, and I thought maybe you could elaborate just a little more. Tell us a little bit the behind the scenes of these kinds of things, because when you're doing digital stuff, you're breaking all the conventions that are out there, you're blurring the barriers, you're getting rid of middlemen, you're doing things directly, you're challenging the system in many ways. Here you gave a really nice example of the behind-the-scenes work you need to do to realign the system. Mm-hmm. You're in a position of power with your digital data, so to speak.
Okay.
But maybe a few more thoughts about what's the behind-the-scene work that one needs to do, whether it's legal, legislative, whatever, to make this stuff possible.
Well, I mean, with the curbside, it really was not something you would lay out for somebody as a business plan, frankly. I mean, it was really just the coincidence of having the big rolling model in a, in a company at Facebook's headquarters. And it just generated a buzz, and we became the people you would go to if you needed something to move in the physical environment. Now, when we did that for the building festival, I didn't have that agenda. Mm-hmm. I mean, I knew it was a good idea. I didn't know why it was a good idea. And I think a lot of people waited to adopt digital technology because they needed somebody to give them the case for why they would do it. And so, but that's not a person who's an innovator. I mean, an innovator will go somewhere because they think it's a good idea, but maybe they don't know exactly why.
So you're kind of a digital guinea pig, so to speak?
Well, no, I think it just, when you get up in the morning, you got to be straight with yourself about whether you're in business to be innovating or whether you're in business to be something else. Mm-hmm. And so, but if you're going to be an innovator, you don't do it by saying, what's the business plan or the case for this? You know, you actually have to experiment with something and figure out what it's good at. And I mean, the first part of the talk, I really meant to say that I was experimenting with something without being very self-critical. Like making things complicated because I could make them complicated. Like that's a little bit the DNA of anybody that's been trained in architecture, but it actually didn't have anything to do with the digital. And it took being with a different industry for me to realize how kind of off that idea was.
So don't get me wrong, when I was listening to you, towards the end, I was like, okay, I know where Greg's going next. He wants to go into space, right?
No, I don't want to go to space.
But I think it's an analogy that might be interesting. I mean, the arguments for going the Apollo 11 to going to the moon was that there's a trickle-down benefit of doing extreme things. Is that how you see this work? Is that sort of, in a way, part of the role of the digital?
Yeah, I think staying open to other industries, being entrepreneurial, I mean, figuring out how to commercialize and monetize the thing in the way that it wants to be rather than trying to force it. Yeah, but I think the space mission, it's a really good example. It's a useless enterprise, but they tried it because they knew they were going to have to invent stuff to make it happen.
Yeah.
And when we did the rolling house, I mean, I remember saying I think we had 70,000 euros to do it. And I said, look, we're going to go ahead and spend the whole 70,000 to do it. But we're then going to have a lot of IP that we can then, if we want to, protect and roll into all this other stuff. Yeah. So I would say there's 7 or 8 pieces of intellectual property that are now part of Curbside that came straight out of that project. So I think that analogy is very right.
Yeah. Well, I'll stop us there. I think that's a really interesting place to be. And thank you again very much.
Thanks for having me.
All right. We're going to switch modes a little bit. Where are you guys? I can't see anybody anymore. There. So